In this lecture, we'll discuss the second topic in section 9.3, electron affinity. Let's begin. The electron affinity is the energy change associated with adding an electron to a gas phase element to form a gas phase anion. Recall that we make this measurement in the gas phase to minimize the intermolecular interactions that could interfere with the measurement. But even with these precautions, measuring electron affinity is more difficult than measuring ionization energy. For the halogens, like chlorine, electron affinity will be a negative value, meaning the process is exothermic, and because it leaves the anion with a lower potential energy than the original atom, this will be a favorable process. For elements with a filled subshell, like the noble gases, electron affinity will have a positive value, meaning that we must do work on that atom to get it to accept an electron. Because of this positive value, we can say it's enthalpically unfavorable. Let's look at some electron affinity values on the next slide. Unlike the trends for ionization energy, we don't see a clear periodic trend in the electron affinities, except to note that they generally become more negative or favorable, moving from left to right. This makes sense when you realize that metals, on the left, prefer to give up electrons to form cations, while the nonmetals, on the right, prefer to accept electrons to achieve a noble gas configuration. Scanning the values here, we see most elements will have negative electron affinity values, meaning they're achieving a lower energy by accepting an electron. Those elements with a positive EA value, which is noted as greater than or equal to 0, tend to be the elements with a filled energy level, like the noble gases, or a filled sublevel, like some of the early S2 elements or any of the D10 elements. Let's work through example 9.10 together. Which four elements release the most energy when forming an anion in the gas phase? Elements that release energy have negative electron affinity values. The halogens, group 17, have the greatest negative electron affinities of all the elements and, therefore, give off the most energy when forming a gas phase anion. As always, here are the parting thoughts from the authors over this material.